Today we're going to take a look at solving a system of linear equations using linear combination or elimination. We have dual names for this, linear combination and elimination, because it does depend on what textbook you read. Terminology is either, and we'll explain why they call it these names as we run through some examples. We also do want to emphasize that this is another method to solving a system besides substitution or graphing. So if I would like to solve a system of linear equations using linear combination or elimination, the important thing we need to realize here is that we're going to take a combination of the equations to eliminate a variable. Let's walk through the steps. The first step is make sure that you write the equation in standard form. The next step is probably one of the most important, and if you understand this concept, it drives the rest of the problem. And what I mean by that is that we are going to multiply one or both equations by a number or numbers so that the equations have opposite coefficients for one of the variables. Well, what does that mean? I'm going to actually do that in a different color. Because what that means here is that our goal here is to get something where we have like a negative 3x plus a positive 3x when we take a combination of those, because we know that those are going to be resulting in 0x, and 0 times anything is 0, which would eliminate that variable. If, let's say, I had a positive 5x, I would work to get a negative 5x in the other equation. Third step here is that we are going to add the equations together, and then we solve the resulting equation for x or y, whatever that variable would be. Once you have that solution, you then substitute that value in to one of the previous equations to allow you to solve for the other variable. And then the last thing we can do here is write our ordered pair as a solution, and we don't want to forget that we can always check our solutions to verify we've done it correctly. Because how do we know that an ordered pair is a solution? Well, an ordered pair is a solution when you plug in that ordered pair, and it makes not only the first equation true, but also the second equation true. So let's take a look at this first example here. I'm going to make note here that as I look at the original problem, I have a negative 1x with a positive 1x. And those are what we talk about. I'm going to underline it back up here, but we are looking at for this idea where we have opposite coefficients, so positive versus negative of the same value for one of the given variables. And the reason this is helpful is because when I add these equations together to make a combination, the x variable drops out and I'm left with 8y equals, and this is negative 24. I then have down here in step 4 the ability to solve this equation just for y. So I can divide by 8 and y is equal to negative 3. Once I have what y is equal to, I then get to move here to step 5, and I get to substitute this into one of the top equations. I'm going to substitute into the second equation, so I'm going to make a note here, and I'm going to say plug into the second equation. When I do that, I'm going to take this negative 3, and I'm going to substitute it right in here for y. So I'm going to get x plus 6 times negative 3 equals negative 16. I'm going to get x plus negative 18 equals negative 16. Add over 18, and I get x is equal to 2. What this allows me to do is to then write my solution as 2 comma negative 3. That's x comma y. How do I know if I've done this problem correctly? We are going to check the solutions. When I go through and check it, I'm going to check right here by plugging into both the top equation and the bottom equation. So I get negative 1 times 2 plus 2 times negative 3, and I want to know, does that equal negative 8? Does negative 2 plus negative 6 equal negative 8? And we know, in fact, that checks. But be careful, that only checks in the first equation. I also need to come back and check in the second equation. So again, now I'm going to plug into the bottom equation, and that is going to be 2 is my x value plus 6 times my y value is -3, and I want to know, does that equal -16? Does 2 plus -18 equal -16? Well, 2 plus -18 is -16. -16 does equal -16. So I know that this here, as an ordered pair of 2, -3, is a solution to that system. Let's take a look then here as we look at problem number 2. Again, we walk through our steps. I'm going to eliminate some of these markings here so we can talk about these one at a time. But we want to double check. Are both equations written in standard form? We can say yes. Can we get a situation where maybe we have opposite coefficients on one of our variables? Well, as I take a look here, I notice that we can do that if I choose to eliminate my y's. Because I have a positive 6y with a positive 6y, the way I'd get the opposite coefficient is to multiply. This is what we pick up here in step 2, where it says multiply one equation to get the opposite coefficient. As I do this, I'm going to be left with -5x minus 6y equals -4. I'm going to keep the bottom equation as is. I didn't need to make any alterations to this because that's where my positive 6y was. And what I'm going to do here is I'm going to add these equations going down. And I'm left with 2x. The y's cancel out. Like I said here, I want to eliminate the y's. And that's equal to 4. Divide by 2. And 4 divided by 2 is 2. I next need now to substitute back in. When I want to substitute this back in, it doesn't matter which one I want to substitute in for, but I'm going to make a note here. I'm going to plug into the top equation. And as I do that, I'm going to get 5 times 2 plus 6y equals 4. This is 10 plus 6y equals 4. Subtract 10, I get y is equal to, or 6y is equal to, 4 minus 10 is -6. Divide by 6, and y is equal to -1. What this again tells me is that my solution is this ordered pair, x comma y, where x we found to be 2, and y we found to be -1. You could definitely take that and plug that back in and check it. I'm going to move on with the next problem because I do know that, in fact, if I were to check it, that would work. As I take a look here at problem number 3, we take a look and we have both equations in standard form. As I look at the problem here, the goal is to try to eliminate a variable. As I try to eliminate a variable, I notice that I have a 2x and a 4x and a 1y and an 11y. Well, I think it would be easiest to eliminate the x. And the reason I say eliminate the x is because I would find that if I multiply the top equation here by -2, that in fact I'm going to notice here that I'll get a -4x and I already have a positive 4x. So let's rewrite the top equation. That's -4x plus -2y is equal to -9 times -2 is positive 18. I'm going to leave the second equation as is. I'm going to add those two equations together. As I do that, I'm going to eliminate the x's, and I'm going to find out that I get 9y is equal to 27. Divide by 9, y is 3. If y is going to be 3, recall that if I would like to solve for the other variable, we're going to substitute this back in. And I'm going to substitute plug into, again, I'm going to go to the top equation. So that's 2 times x plus the y value we're going to substitute in is 3, and that's got to be equal to -9. Subtract 3, 2x is equal to -12. Divide by 2, x is equal to -6. When I write my solution, again, my solution is this ordered pair, which is -6, 3. Next problem up here is problem number 4. As we take a look at problem number 4, we again double check. Are the x's lined up? Are the y's lined up? Is there a variable that is easy to eliminate? As I look, I have a 2x and a 3x. Both of them are positive. I also have a negative 3y and a positive 4y. To be honest, you could choose either. I'm going to choose to eliminate the y's. And the reason I'm going to choose to eliminate the y's is because I already have the top one being negative and the bottom one being positive. What I need to do is just find the multiple between, the common multiple between 3 and 4, which is 12, right? So if I know that, then I'm going to multiply the top equation by 4. That is going to give me a negative 12y. And I'm going to multiply the bottom equation by 3. That will give me a positive 12y. And when I add those together, they're going to cancel out. So let's rewrite this below and see what it looks like. Distribute this 4. That's 4 times 2x is 8x minus 12y equals 24. We get 9x plus 12y equals negative 24. Remember that the reason I said we're doing this is because my goal is to eliminate the y's. So here my y's have been eliminated. And I get here 8x and 9x is 17x equals 0. Divide by 17, x is equal to 0. When I go to solve this, I'm going to plug into, again, it doesn't matter. I'm going to say the bottom equation in this one, just because the last one I did in the top. It's not going to really matter, because I'm going to get 3 times 0 plus 4 times y equals negative 8. So that's 4y equals negative 8. Divide by 4, y is equal to negative 2. Again, my solution is x comma y, which is 0, negative 2. If you'd like to verify that works, check that both in the top equation and the bottom equation, and it will be a solution of each. Next up will be day number 5, homework, which will give you an opportunity to practice this concept that we discuss as linear combination or elimination. Again, it's a linear combination because you're combining. We'll highlight it here in the last one. We're combining by adding 2 equations together to get one equation that allows us to solve for one variable. It's also called elimination because the first step is to eliminate one of the variables, whether that be x or y. We will practice this today. Best of luck, and we'll talk about it tomorrow.